Hi everyone, this is Jess Minnickbach, and this is my Week 8 data analysis presentation. So before sharing the data I want to analyze for this presentation, I wanted to give you a bit of a class overview. And so I pulled the data from my STAR Math assessment, and I think it's important to share prior to showing my Math Chapter 1 assessment data because I am a third grade teacher, but many of my students are not on the third grade level. So you can see here I have one student who is on a third grade level and ready to learn third grade skills. I have some students who are on a second grade level, and then it tapers off to first grade, kindergarten, and even goes down to some students who are on a pre-K level. And so you'll see a great range of scores in my Math 1 data, Chapter 1 data, because of the variability and ranges that my students perform at. So here is an example of the Chapter 1 test. I screenshotted the different pages. This is a bit of a lengthy assessment, I think, for third graders at the beginning of the year, but it's a 26-point assessment. There are 22 multiple choice questions and a 3-part open-ended question that was worth 4 points. And this test was assessing students' ability to add and subtract multi-digit numbers, as well as estimate and round. So the descriptive statistics for this data collection, the average score was 54%, and the range went from 15% scoring 4 out of 26 points to a 98% scoring 25.5 out of 26 points. So I put that on a graph so you can see the range of scores. Here's that minimum of 15%, the maximum of 98%, and so you can see these scores here when I was comparing the test scores to the STAR data. These students were the ones scoring ready for third grade skills, the second grade skills, and so those students were scoring fairly well on the assessment. And then as the students' test scores got lower, there was a correlation between students, learning ready for pre-K kindergarten skills scoring fairly low on this assessment because, they didn't have the prerequisite knowledge to do a lot of the content that I was teaching. So we'll get further into that. This red bar here is the mean. So you can see many students fell below the mean and most students scoring in that 40 to 60% range. So to break this down a little further, I did an item analysis. So I put an X for each question the students got incorrect, and this 23 here is the open-ended. So I scored that from a 0, 1, 2, 3, or 4. You'll see here there's 2 sets of data. So I first went through and scored the students' data, or scored their test, and then I gave it back to them and let them revise any of the questions they got incorrect. So that you'll see here is designated by the red X's. Those are questions the students initially got wrong, but revised them to be correct. And I factored those into the students' final scores by giving them half credit for them. The S's you'll see scattered throughout are students who skipped a question and did not answer it. All of the students, they were given the opportunity to revise. Some students were absent for an extended period of time, or they just simply refused to revise the test, so they only have the 1 score, but all of them have a score in red, and that's what was used to factor into the descriptive statistics and the graph. So breaking this down, the interpretations, questions 8, 9, and 10 had a low success rate. There was a lot of students with X's. Here, for example, question 8, there were 3 students who initially got it correct and 6 after they had the opportunity to revise. So 3 out of 19 or 6 out of 19 isn't the best odds. So looking back at these questions, students were solving a subtraction problem, and when analyzing students' questions, students' errors were a combination of using the wrong operation, even though I guided students with this test, with it being our first chapter test of the year, and I wrote out a subtraction problem. Many students still chose to add. There were basic subtraction errors, and they were failing to regroup. And so this is definitely something that I need to be mindful of in order to reteach in the future. And another area where students lost points as a collective group was the multi-step open-ended problem, and students were required to add multiple add-ins together. They were required to read data off of a frequency chart in order to solve the problems, and many students were confused by that, and I thought that was just a little bit unfair because Chapter 2 introduces them to data tables and reading information of charts and graphs, and so I was wondering if there was a different way the data could be presented to the students in order for them to solve those open-ended problems. So my overall interpretation, I collected quantitative data, and these are numbers and test scores, and the assessment came with a scoring key, and therefore each assessment was scored the same way, which increases the reliability of the data. The data that I collected for my Chapter 1 test aligns well with the STAR math test data that I showed at the beginning, showing that many of my students are performing below grade level, and students are performing below grade level. They're lacking the prerequisites for this skills in order to solve these problems. For instance, students are adding and subtracting multi-digit problems, but many of my students were still struggling with strategies to solve simple addition problems such as 6 plus 5. And we had to spend a lot of time using those strategies, just get a sum for that, let alone the regrouping, adding multiple place values together. So going over simple addition, subtraction, place value, skip counting to introduce rounding. It was a lot of prerequisite skills, and my students had no idea how to even start solving some of these problems. And so it's crucial that students have the knowledge of the skills taught in previous grade levels to learn new skills. I know this is an issue across my building, and I'm sure teachers across districts and states are having the same issue, where students between a lot of virtual learning, interruptions to learning, and the fact that I teach in a low-income district, a lot of my students are Title I, there's a lot of other outside forces that impact, how they show up to school every day, and so our test scores in our district were low to begin with, and so the effects of the pandemic just exacerbated those, how low performing below grade level our students were. And looking back, it would be beneficial to give differentiated tests to show growth for my students performing below grade level. I know this is an issue that many teachers in my building have brought to administration. To me, it almost seems unfair to be giving these students a third grade test when hardly any of them are on a third grade level. But we were told we have to give our grade level assessments regardless. So a solution to this, I'm going to be incorporating intervention, my math intervention groups, and collecting data there. And so I can, I already was doing that with targeted progress, but I'm going to start collecting more data by giving a pre-test, a post-test, to start showing student growth. That way I can show my administrators and show during parent-teacher conferences that even these lower students who are performing poorly on our chapter assessments are still making progress toward the third grade standard by acquiring some of those prerequisite skills. So then I just had my references with the Mills text, and I'm looking forward to seeing everyone else's data interpretations and analysis. Have a good night.